I'm on time, but don't expect too much. Oh wait, I need to start TTS. This join my Discord to get TTS if you don't know that yet. There is a TTS channel. Hello everyone, hello Dodge Taurus, Christian, M40K, Louis, Jordi, Tech, and Johnny. Hey everyone. Can't hear anything yet. Did I mess up something? Uh-oh. Poot-doop, poot-doop, poot-doop. There is nothing. Let me restart. Trigger again. Can't hear it. Nope. It's your bitluni. I'm not responsible for TTS breaking. So how is everyone? I'm completely unprepared. That's why I'm on time, because I didn't have to set anything up. But hey, Sion, I watched your stream, rewatched it before, like an hour ago. Yeah, I needed a shorter hair for the warm California weather. I'm going tomorrow, my dudes. No music today. Oh, I'm getting warm. Okay, so the only thing that I prepared today is some food, because I had like to cook something really quick. So I made some fake börek, which is basically like white cheese with some how is it called, petersilie. Yeah, whoever knows what petersilie is. But I didn't took like the proper dough for börek, the Turkish dough. I just took blätterteig. I don't know what's the name of blätterteig. What's blätterteig? Let me my saliva, but I burnt my tongue already. So blätterteig English. What's blätterteig? Puff pastry. Yeah, it's basic puff pastry dough. And what else? Petersilie. I always forgot parsley. Yeah, it's basically parsley, white cheese, and hey, Aaron. It took me 5 minutes to prepare that. Just rolled the cheese, like mixed the cheese with the parsley, then rolled it in slices of the dough and put it in the oven. Done. Mr. Sion, you are up early. You're still jet lagged from last week. Okay. So FPGA stuff working well. I can show. Where's my screen capture? Oh, I need to move it. Here we go. Yeah. Yeah, my new code is like very simple. Very simple. It's only like few files and some real-time stuff, but I unfortunately discovered like some limitations. I can do only like 2-3 passes of the Julia set, because then I run out of DSPs. Apparently, to do big multiplications, we need a DSP, and that's a limitation. So I don't know how to proceed there, but this is something that we will do later. because first of all, uh, why is bitluni not working? What's happening? Or is it my stuff? I can't hear you. Oh, it's with me? Shit. What's happening here? LG Web OS TV. Oh yeah, that's file. What's going on? Why isn't my time chat not working? Oh no. Hey Anchi. Uh-oh. Yeah, it's with me. Can you trigger can you trigger something else with the bitluni? You have the control room. Time for a reboot of what? I don't know actually what's happened. We can check. We fix TTS first, okay? Here you go. Screen capture. Boop. Oh yeah, test. Oh, this is working. Okay. So we get something here, but what's happening here? Maybe YouTube changed API. What is this? Bin bash. USB. What is this? Crap. Okay. Whatever. This is not interesting. Filter messages. Let's check the debug output here. Boop. And see what's happening there. Uh-oh. Something's broken. Code. Hä? Oh, wait. YouTube breaks everything. Ah. Okay. I don't know why this complains. This return code. Error. Let's try again. Or let's check return code again. Return code is 0, which is okay-ish. And what do we receive here? Let's check the whole ordeal. Oops. Uh-oh. Let me stop that. I got the monkey. Here. This is the page I receive. Uh-oh. Yeah. Yeah, I'd say so. My request is broken. Let me check my request. Oh yeah, that's the one. Oh, undefined? Oh, yeah, that's a problem. So the filter videos doesn't work. Oops. Let's check what filter videos responses. I might need to fix that. Wait. Reset that one. Drop everything. Is this an error? Uh-oh. Wait, where are we here? We should get a... What is this shit? Yeah, we might not be able to use TTS today. I don't have as much time as I'd like to fix everything. Let's see. But I could inject it manually. Error. Yeah. Probably some of my tokens ran out of time here. Okay, let me try something else. This is a reset. Filter live streams. The return is streams. Payload 0. We can fix that here like that and set the video just here. So what's the video? I will just trigger this manually and we fix this when I return. Where's my... Let's see. It work? Oh yeah. Oh. Okay. Good. This was the first issue fixed. Erroluni. Yeah, YouTube probably just changed their page. Okay. What? We have memes? Ah, doesn't work. Ein sehr guter Abend. Hey, Dutchmaker. Okay. I should add. Okay. So, the thing that I want to fix today. So, you know, the problem that I dox quite often myself, and my laptop is shitty. You know, my laptop is loud. It's a Dell. It's loud. The fan turns on. It's embarrassing and it's heavy. And I didn't want to take my laptop with me, especially with the broken battery. So I have a tablet, which is great, and I got the keyboard cover for my tablet, and I thought, okay, why don't I just take my tablet, which has no fan and no noise, and I can, instead of buying a laptop, I looked into laptops and they're all like, I'm not satisfied. You can get a Chromebook and fix that, like put some other operating system on that, but I couldn't decide. But what I could decide on was this thing. This is like a small PC. It's the Miliquieter 3C. I can drop you an affiliate link if you want to. Amazon bitluni.net, and it was a mini PC. Okay. If you want, there is like, I got a coupon for that. Like you can apply on Amazon a coupon which you get a discount, and it was below 300. Still 300 is quite expensive, but this is amazing. It's passive, no fan. It has two display port, HDMI port, Ethernet. It can be powered from power delivery. It has audio jack. Then we have display. This is USB USB-C with display and power in both directions, and some USB 3 ports, which I have like a keyboard dongle attached. And this thing, it runs Windows 11, and it runs not only from this power bank, 12 volt power delivery, which is 10 amp hours of, but I got this power bank as well, which is the same capacity, 10,000 amp hours. It can't deliver like as much amps. It's only like 1.5 amp hours at 12 volts, but it can still power this device. I can show how that works. Okay, let me connect that. So I will attach. Oh, or let's show it later. Yeah, slow. But if you're coding and developing, most of the time you're typing, and good performance in typing was solved like, yeah. So this is like my pocket solution for a Windows-based like PC. Okay, but yeah, and the thing is, I can use with my tablet, I can use USB tethering and use remote desktop or whatever to use it with my tablet. So I have a completely silent solution for the airplane. Oh, they are really great. Oh, the new ones, you can play Skyrim on that, like with no issues. So they are powerful. That has 8 gigabytes. Should I open it up? I will open it up. Yeah, I will sell this item to you. Okay, I will open this up. I didn't open it yet, so this is the first time live that I'm opening it. That's a new generation. It's from last year already. I think it was like published last year, the generation of Celeron. And Halo, yeah, most probably. You can run a lot of things, emulators. It can output like 4K. Oh wait, I need to remove the dongle. Okay, here's the plate. I need to put this back on when I'm done. Look at this. These are the passives from the heatsink. And here, look, there is an extra. So you have, I took the smaller version with 128 gigs of SSD, which is soldered on, but there is an extra slot for a full-size SSD here. Nice, isn't it? So, yeah, it has Wi-Fi. Okay, I can show the features. So I was curious about this. That's why I got it. And I thought, why don't I use it for my development stuff? Where's the, oh yeah, here. Here you go. Here are the specs. Yeah. Okay, so specs. Windows 11 Pro, it comes with a license. Then you have the N5105, which is the version that's already like twice as good as the J version from before. Many of the the problem with Apple is that if it was, I would consider MacBook Air. Yeah, it has Wi-Fi. It has Wi-Fi. It has Wi-Fi. It has Wi-Fi. It has even micro SD card slot if you need. An audio jack. One-time HDMI 2 at 4K 60. Display ports 4K 60. USB-C 4K 60. USB 3. USB-C. Then you have Bluetooth 5.2, Wi-Fi 6 at both dual band. And yeah, so this processor apparently is not that bad. You can check out reviews. It's great. I will close it now. I want it working in a sec. Oh yeah, they look the design. Since this is a metal case, here there is no anodization, and here is the pad to connect it. But there's, oh, did I lost it? Should the USB be also connected? I don't think so. I don't know. Okay, here we go. I close it, and I will show you how it performs. We can test it out. Probably, but you have to be careful. There is the C and the Q version. The Q version is a little bit 3C. The Quieter 2 are with the J CPU, which are way cheaper. You can get them for 150 maybe even, but they are way slower in graphics performance. So unfortunately, it only has like the DDR is only how's it called, one lane. So it's not using the most performance that you can get from this CPU. But there was no 16 gigs version, 16 gig RAM version, otherwise I would buy it. And it also comes with a VESA mount plate, so you can basically, it's quite light, I don't know, 300 grams. And then you can mount this to your TV and use for whatever you, as an emulator, or yeah, it's an alternative if you want a x86 based mini PC, which is absolutely passively cooled and can be run from this battery. This is cool. I will show it. I will show it later. Now, but obviously taking this with me with like extra stuff, mouse and so on, it's like an extra contraption. It's a lot of stuff. I got also like this thing. This is cool. This is cool with Ethernet for my tablet if I want to take that with me, and other stuff. But I thought we have an open also eine Rechnung offen. So we got last time, I tried to replace the battery because I couldn't take this with me. Much worse. Okay, here we go. We tried to replace, I didn't even screw on the batteries back. Screws on. And this is the original battery, and we tried to replace it on stream already. Unfortunately, I bought a crappy replacement that didn't work. It didn't work, but I ordered a new battery. And we should try to replace that and see if it works. If it works, I might still take my laptop with me to California. It's way easier. Even though I hate the fan. I hate this. The noises and the heaviness. I'll check if I can use like my mini PC. I could basically I could control it with oh, don't show too much. With control with my phone like that if I want to, or even like connect the mouse here. And this is my oh, really? You ran your from one charge 6 months. That's a good battery. Which one did you use? The Anker power wall. This one here. I take this with me and my PC. At least that can run the PC for a few hours. Okay, but I don't intend to edit anything when I'm gone for 10 days, by the way. Oh yeah. But looking into the stuff, into the PCs and what the new developments are, I came across what is it? Windows 11 on ARM. No, Windows, no. What is this? Yeah, Windows 11 runs on ARM PCs, and yeah, 3 hours is like 2.5 hours more than I get on my laptop right now. So apparently, if you run Windows 11 on an ARM like a Snapdragon or whatever, it is able to emulate x86 programs. So you can still run your old software, everything that you ran before, and run it passively on a Snapdragon, which is really cool. And yeah, it's Windows 11. But then I thought, okay, the FPGA software is also available on Linux. Maybe I should try Linux. Oh no, I might. So everything I need is a browser, because the most things that I code are for browser anyways. If I make tools, then I need the FPGA software because I'm in the rabbit hole. That's available for Linux. I didn't test it, I checked it, and there are the open tool chains for Windows 10 on ARM. Yeah, did you test it with Windows 11? I would be interested in the performance comparison with that. Maybe I have to watch a few more videos on that. But then I thought, okay, I could buy a laptop like the new X1, ThinkPad X1, which has a Snapdragon, passively cooled, no fan noise. It runs Windows 11, but I want to put a partition with Linux and to run Linux on that. And obviously there is already some people compiling kernel. We had this yesterday. I think it's in the Hangout chat somewhere. So I might switch to Linux soon, because of the fact that I don't want fans on my laptops anymore. I want really efficient laptops for traveling, thin, light, maybe Chromebook, whatever. Put Linux on that and suck it up. MacBook Air, but MacBook Air is really old now. You can't run Windows on M1, can you? Or M2? I want like the the state-of-the-art hardware, even if it's ARM. Just stop traveling. Just use the remote desk. Yeah, but then if I'm not on an airplane, I don't have a connection to whatever. I can use that. Yeah, this is my solution. So if I'm traveling, I can take a small laptop, super light, super thin, whatever it runs, Linux, Windows, and connect with that. What? M2 runs Windows 11 better than the... Is there a Windows 11 build for the M2? Ah, virtual machines. There you go. Yeah, I installed a virtual machine Camu on my tablet, which is Galaxy S7 Plus. It's apparently not that bad, but the emulation was so slow, it was unusable. It wouldn't even boot up. I don't know why it didn't boot up at the end. Oh, wait. Headrest screen. Wait a minute. I didn't think of that. I mean, I can still use... So, what I have is the grabber card. I can connect... Oh, wait. I can connect this thing with... I will hold nuts. I can connect HDMI out to this HDMI grabber card, connect this as a camera to my tablet if anything goes wrong. Did anyone try to connect with the monitors at the... Oh. What's this? Okay, so let's switch the battery and see if I got lucky this time with the battery. Otherwise, I need to send it back immediately before the company goes away where I bought it. Not to have it the same way like last time. Oh, wait. Can I? Yeah, the battery swap shouldn't be like... Let me grab the tripod. By the way, I don't stream too long this time. It was a long stream last time. Was it? I can't remember really. Oh, we are still good. I want to keep it 2 hours this time. Even though I prepared my clothing already, don't have much space with all the tech that I want to take with me. So my plan is go to SuperCon, and maybe after that I want to rent a car to go to Grand Canyon, because I was never there before, and I take my drone with me. So, and I hope I can rent the car with a debit card, not with a credit card, because my stupid bank, I tell you, they changed everything. They basically cancelled the old card because they don't want to provide it for free anymore. And let's say I messed up not to agree on the paid credit card. And then in Ireland I had a problem that apparently car rentals require a credit card for the safety deposit, which they reserve on the credit card, and on the debit card that's not possible. I found a rental place where I could basically pay them like the deposit with the debit card and get the car, but not all rentals did that, so I'm not sure if I get a car. Okay. Let's see. Switch it. Capture. Whippa. Here we go. Oh, yeah, I'm capturing in 4K. Whoop. But you are not in 4K. Here we go. Bloop. Oh. Huh? Why is the TTS gone? What happened? What happened? Hey? Did I drop from the TTS? I couldn't hear you. Huh? What's happening? Is it broken? Do we have more errors? Oh no. Okay, here we go. Yeah, let's try. This is the old battery. I didn't even secure it. Dell design is so stupid. I uploaded on TikTok today the swap of the battery of the Acer Swift 7 for my girlfriend, and it's way easier. They have like only one screw size, and internally it has only like 2 screws, snaps in, everything works fine, no gatekeeping with some ID chip for the battery or whatever. Scotty, I think so. I was too scared to talk to him last time because I'm an anxious nerd, just as you all are. And this time I will just ask him because I really want to organize some kind of trip to China, to Shenzhen, in the near future. Hopefully next year, if they yeah. This doesn't even fit. What the fuck? This plastic doesn't fit over the metal things. Before I start drilling that out. Really? Okay. Yeah, Dell is some shitty gatekeepers. Let me just put this on so I don't short anything with some random screws and see if it even boots up with this battery, and then okay, we have a fan spin, which I hate. Okay, let's see if it boots up. A framework? Yeah, but framework is with fans. Okay, battery works. Nice. So, let me turn it off again before I dox myself again. Oh, by the way, I needed to sign that I'm COVID free, that I'm vaccinated. For US, I need lots of documents. Sian, why are you muted for me? Did you pick the wrong language? Did you turn your off? Can you select a language that's like exclamation mark lang an or something? Yeah, you just need to bring and sign this like 6-page long thing. At least my Condor claimed I have to bring that with me, print it out. And then there is this Esther thing. Lang, not lan. No, no fan. No fan. I tell you why no fan. Fans are a trap. Okay, I need to drill it out. That's too tight here. I will just take this here, and I think I will just. Oh no, not good. There's not enough steps. You know what I mean. What size is that? Let me take a caliper. So I take the proper drill and fix the plastic tabs for that. So we have here it's 4.68 and this is 5. Okay, we need 5 millimeter. Oh, this is actually 5 millimeters. Ah, perfect here. Fixed. Yeah. That's what you say. But the problem is, if you have a fan, even if it's silent, it's only silent when you get the PC. And then when it clogs up or when the ball bearings break, even if it's like super fancy whatever ball bearings or shit, where are my screws? Uh-oh. I think I had a small bag with the screws somewhere. Oh no, I lost my... Shit. Where are the screws for this one? Oh, wait! I might have put them away somewhere here. Where are they? My screws for the laptop. Yeah, it took me longer to swap it than expected, and now I can't find the proper... But who needs screws there anyways? It's not like they would consider attaching the heatsink to the aluminium frame. Stupid design, lazy design. They just ship it, the Dell people. They might have improved since then, but at that stage, where the F are my bolts and screws for that laptop? I lost them. My huge pile of... You know what? No, that wasn't that one. That was for the VESA mount of the mini PC. I had a small bag of that's long time ago. Oh yeah, FPGA. We will start with the FPGA stuff in 11 minutes. So one hour of setup and Okay, whatever. Okay, here we go. No screws needed. It snaps on anyways. Okay, here we go. Laptop fixed. Now we need to recharge it, huh? Nice. Okay, that's that. That's that. I need to recharge it now, so I will take the power supply and recharge the new battery. Do I have a slot? Oh, blip. Here we go. Oh shit. What? Yeah. Why did you deactivate Twitter? What's going on? Did I miss anything? Here we go. Everything's all right. Okay, FPGA stuff. Oh, Aaron! Thank you very much. Start for. Oh, yeah, I need 100 more of those to afford the laptop that I actually want. Thank you. No more Dell. No more Dell. So what brand? What brand should I take? Don't say Apple. I don't want an emulated Linux on Apple or anything. I Oh, interesting that you say that. It's like the same feeling. It's the same feeling that I got. I mean, most of the time, it seems like arguing with people on Twitter is like totally pointless because everyone is in their bubble. Nobody is open to new opinions. And I get the vibes that I had with Facebook at some point, that it's basically pointless. I rarely use it. Twitter is toxic, yeah. That was the worst investment of Elon Musk. He will probably regret his life choice there. But what I liked about Twitter is like the instant news, that you can really get information from like different countries and areas where basically there is no open reporting or press or whatever. So for that reason, Twitter was like the best platform. 9gag is as well. If you scroll 9gag, the probability is high that they will be notified of some events going on in the world that you didn't get from the news yet. Oh, you have your Mastodon. Okay, maybe I will join. I will try. I will sign up. How do I sign up? Find the server. Can I sign up with your server? Okay, I will do it later. Yeah, Mastodon Social seems to be completely overloaded right now. Oh yeah, I have the sour gummy bears, but they are somewhat like very hard right now. Okay, back to the big deal here. Baroblique. Okay. So much stuff going on here. Oh, really? Here we go. That's a good one. Never read any tweets. Okay. No. I'm done with setting up my own servers. Basically, I don't have any time for that. Nobody ain't got time for that. What is say on to? Yeah, not reading. Okay. Yeah, we can use that. I will just connect to this screen here. We can, yeah. Bloop. Wait, wrong window. Okay, and here is, yeah, here HDMI, and yeah, where is need a longer cable? Where is the long USB cable? USB-C. This is B. Where's my long USB-C cable? This chaos in this lab. Oh, this is a Tang Nano 9K. And if I ever find oh yeah, thanks. Where's the long USB cable? Huh? Oh, yeah, I collected them earlier because I want to clean up. Okay, here we go. Long cable here. I don't know what the state is of the code currently that's running on the Tang Nano. Here we go. It might just die. Okay. Oh yeah. Yeah, that's broken. That's like one iteration of Julia set, second iteration of Julia set. Yeah, first, second, third iteration. And here some sign errors. I don't know how to fix them. Oh, I wanted to show you how the new thing works. Okay, so I need a second HDMI. This one should work. I'll connect it to my mini PC. And I will connect it to this battery here, okay? To this small battery. And we'll see if it runs off the... It runs off 1.5 amps. Okay, I turn it on. Here we go. Where is it? Is this the one? Nope. It's not that one. Oh yeah, here we go. That's the Intel. graphics. Oh, what resolution is that? Is this? Okay. So this is the small PC. Let's see if it switches resolutions again. What resolution is that? Uh-oh. Let me move the window. Ah! Okay. Let me check that. Display settings. Not now, mister. Here we go. Display resolution. Oh, it picked that one. Okay, let's do that. This is the highest resolution? That's like nice. Okay. Let's do that. Keep changes, and I need to rescale. Huh? It's strange. It cropped. Okay, here we go. It's only 20 euros. You can buy one and... Okay, whatever. What do you want to see on the mini PC? What do you want to see? Oh wait, this is stuck. No. Your earwax it is. Yeah. Okay, how do I use it? Okay, obviously I need a mouse. Let me connect my mini mouse. And I would need like a numpad. Oh, thankfully. Higher level menu stuff. Okay, so do you want Oh, what? No, no framework. Take it back. Cancel your donation. I don't get a framework. I don't want. But thank you, Louis, very much. Thank you. Even though you might take it back because I don't get. I will only. Oh, here is. Oh, wait. You can see anything. Okay, here is my numpad. Do you know what this is? Look, it's a Bluetooth numpad. So if you're working with Blender, I bought this only for Blender. It's a calculator with a built-in Bluetooth numpad. Do it. You need that? I bought it used. What? No! Oh! See? MacBook Air. Never. You will hate me, but if you don't don't cancel this super chat. I will buy something completely different. Never I will get an Apple device. That gatekeeping asses. But thank you anyways for the super chat. Oh man. We should do what? Johnny, what? MacBook. Who of you is using a MacBook Air? Thank you, Johnny. Never Apple. Yeah, I am wrong. Yeah, I admit 40 years of my life. Oh, Dutch Maker, you do. But are you using the M1 or M2? Is there even an M2 already? ThinkPad. Okay, that's what I'm talking about. I rather spend. Oh, no, fanless design. Fanless design. Okay, I will get a framework if there is a module like a huge passive heatsink that you can attach to it. That can we build a heatsink with static airflow, like charging it up to few kilovolts. Okay, however, can we render this? Can we ray trace this? How do I ray trace? Oh no. What did I do? Ah, there it is. Uh-oh. No, my CPU is only 6%. It's not my stuff. Okay, however, my mini PC works nice, okay? I think I stepped on my mini mouse and now all the buttons are broken. Don't save. Okay, here we go. Fusion? I didn't use Fusion. Is there... the mouse is... I stepped on the mouse and I think I broke all the... Okay, here we go. Yeah, but you didn't have had many laptops before. I had a expensive Sony laptop already. I had an expensive Dell laptop already, and I'm disappointed. The Sony was okay though. Yeah, but I don't want Mac OS. I rather do Linux than Mac OS. Okay, how do I use... How do I use that? How do I use this thing? Can I load an example file to see how good it performs? Are there any... You're still meeting in Hackspace from US? Let's see. Okay. Oh, look at this. How do I... Oh. How do I rotate it? Dudes. How do I... Can I move this? Ah, fool. Okay, how do I... Maybe I render this frame. Let me render this frame. So it looks like we can use that nicely. Can I? Yeah. Yeah, Ash, that's... What? Are you kidding me? That's not... It's not that bad. Okay, so... Fool. This mouse doesn't work. I broke all the keys, all the buttons. So, what do you say? What do you say? What do you think? This is running... the HDMI cable is short. This is all running. Here. This is running on from this battery on this mini PC Fusion with this crappy mouse. Okay, 4K YouTube. Okay, YouTube. I will play a 4K YouTube for you. Let's do it. It will have some dropped frames, I tell you. I can tell you that. Don't save. Go away. Close. Okay. YouTube. Ah, no restoring. No. Okay. Okay, this YouTube 4K. Let's... Yeah, I will. Yeah, we just... Oh yeah, saw this. Oh yeah, reject all. Oh, now you have to watch all the ads. Okay, let's switch to 4K. Okay, that runs. What do you say? What do you say? I mean, we probably were the stats for nerds. We get dropped frames. Yes. Oh, look at this. 23 dropped. But that was probably at the beginning of the stuff. Let me do something. Yeah. Ah, we lost the frame. We lost the frame. I mean, I upload only the highest quality video. Oh, we lost few frames. Okay, there are some lost frames here and there. Yeah, but oh wait, I put on the heatsink. I put my battery on the heatsink. That's not great. Okay. Oh yeah, here we go. Skip ads. Who runs ads on my channel? Are they people crazy? Oh, we lost frames. Oh, another lost frame. Oh no. Oh, what? Another ad? What the Who is this bitluni guy? He is a complete sellout. Turned on mid-roll ads all the time. Foo. Okay, whatever. Okay. Are you convinced now? It still runs from the battery and intense demos. Oh no. No, no, I don't want. I want. Okay, whatever, my dudes. Sign out. Oh no, here. Shut down. So this thing, apparently, battery, still good. It's still full. Love this mini PC. Mwah! This will be my development whatever thing. Okay, back to coding. We have only 45 minutes left. I might install the game pack. No. Crank up. I cranked up the S to pay my rent, my dudes. Yes. Yes. It exists, apparently. Charm high PC lol. Okay. Every time someone says charm high, oh wait. Someone says charm high, Sion instantly gets like a flashback. He has some PTSD from charm high machines. Okay, so I want to change my code I'm changing the complete code for the Julia set. Wait, what is this? Oh. I die a bit more inside when I see that. Salary? No. For a router. Okay, so what I did before is I had some Julia iterations which were consecutive. Now what I want to do is run. Where's my face? Can I switch to another mode here? Boom, here we go. Oh, nice. Yes. No, it's not. Whee! Julia. A Julia set. A fractal. So, what I wanted to do yeah. So, my plan, now we need some ash. Now I will calm everyone down because we will do some serious FPGA developing. And Ash is the only person who is totally into it. So my new plan is not to implement fixed iterations of the Julia set. Bitluni scrap, yeah. Oh no, where do you live? In a car? Okay. So before that, I had like some fixed. Can I show that? That's somewhere on GitHub. Somewhere on GitHub, I have the older code. So what I want to do is what I'm not experienced in Verilog, and this is now System Verilog. I switched to System Verilog because it has the possibility to use like arrays of stuff. So I could set up like 56 array of like words of 32 bits. So this is something that I really wanted to have, and that's only available on System. What? No. This Verilog complained about it. I wasn't able to do arrays. Or I did them wrong. But whatever, I mean, most probably we can. Oh yeah. Yeah, most probably. Okay, so what I wanted to do now is I wanted to use only one instance of the Okay, so what I'm stuck the last time. Oh. By the way, this is on GitHub. If you check out my GitHub, you get certain stage of that project that I committed. If you get Okay, bye bye, Sion. Thanks for dropping in. My signal, yeah. Yeah, I use that quite often, even. Where did I use that? Oh no, I used it in that game that I posted. There is a site where you can learn Verilog, and you have riddles to solve. And oh yeah, I will. I will. Thanks. I will say hi to Dave Darko from you. Okay, everyone's leaving. So I want to only like when I get a clock here. So this is my plan. I get a clock. Also leaving in 5. Yeah, I see you tomorrow evening. So where do we meet there? In the bar or whatever? Apparently, it's, yeah. My flight is going, wait. My flight is going at, oh, you're not going by train? Okay. In the evening or morning? Maybe we share. Oh, Dave, Tony mentioned that you know a cheaper way to get from the airport to our hotel. Cheaper than Uber, because that was like $60 last time. Wait, check. Let me check my ticket. Maybe I'm at the same time, so we can share a ride. Oh no, 17:10. So 5:10. I would have to wait for a bit, but I want to check in the hotel. Yeah, but I would have to wait like 2 hours. Dogs the ticket. And someone cancels the ticket for me. Assholes. Hitchhiking. Yeah. But my PC is so small I can hide it so I don't get robbed. Hitchhiking. So the most expensive part about taking an Uber from the Lex airport is that there is a designated area and you have to pay up for that. So if I take the bus just for a bit and then leave the bus and take an Uber from there, it's probably way cheaper. I don't know. When I was going back last time, I was taking the bus and underground, and that was really scary. So crazy people on public transport in the US. Yeah, I checked in already. I won the seat roulette. Not like super great seat, but it's not like the middle seat. And I'm directly at the hallway, so I can stand up quite often and not care about asking people if they. Yeah, that's what I used last time. But last time on the way to airport. You tagged? Oh, okay. 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 Back to this. So see you tomorrow, Dave. Crazy. That will be like, oh, the trip is so long and I have still to pack everything. It's unimaginable how much effort it is to get there. So now I want to have the iterations of the Julia set all being independent. I tried to optimize, nothing worked. Yeah. So what I want is that the clock reads out the iteration count on the fly. That's why we struggle with the timing. Fraktint! Yeah, it's the best. That's how I learned what crazy resolutions were supported on VGA cards in DOS. They had like all the implementations of all the crazy, not even VESA, it was. Okay, however, every clock cycle, I want the Julia iteration to start Oh no, I'm doing fixed point, but apparently it seems like it's buggy because I have some sign issues here. Usually, since it's running on the DSP, camera out of battery. Oh no. Hey, hey. Very dense stream today. Oh, fool. Don't have. Ah, here. You can plug it in here. Ah. Hello. Okay, here we go. Bloop. Okay. 4. Did I dox myself? Again. Okay, here we go. Hello. Oh yeah, that's John Carmack's implementation of the fast square root, inverse square root with a magic number. But that was like I think a Newton iteration. Okay. Okay, here we go. Oh, he saw that in a book. Yes, it has some RAM, but I don't want to use it. I could do it. Now you got me. Okay. Here. Yeah. Yeah, that's the same. That's the same with the GoWin. It has some. It could be fast enough, but it's limited in size. Especially on the one that's on the Tang Nano 9, I think it's only PS RAM. Yeah, PS RAM, but the PS RAM is also limited in speed, so we can use it. Okay, so usually when you calculate the Julia set, you would calculate the iterations for 1 pixel and then count the iterations and then display whatever color you assign to that iteration. But if you have if you have like the approximated distance to the Julia set, which is calculated here, I think that's like first derivative of there is a paper on that, but this is the distance function, the approximated distance function to a Julia set. That's what's used for ray marching. What you could do is you could calculate you can calculate the distance. Oh, the TTS is going crazy, people. No, it's not scary. It's like other people did the math. You just need to take it and use it. So, but okay. I have to unpack Paint, MS Paint. Here we go. I will show you an approach how to. Oh man, stop! It's not scary. Okay, so usually you would calculate. let me shift that. Blop. What I'm doing now, you will calculate like one iteration, second iteration, and forget imaginary numbers. Just assume they're a variable with two values, like a vector. You just take a vector instead of... Lass die doch mal fliegen. Okay, so you have like a coordinate system, and you basically start your iteration. There is an explanation of 2/3 blue, 1 brown, or 2, 3 blue, 1 brown, or what's the name of the channel? And you will basically calculate for this starting point an iteration, the iteration count with your threshold where you cancel. And the count of iteration you assign a color to, and you can basically render pixel by pixel. So, and now what we have, oh, let me just, yeah. What we can do for the ray marching stuff here, ray marching, people figured out that's like really old. Yeah, that's just vectors. 2 components, and quaternions are 4 component vectors. And this is basically, it's the same here. This is our calculation of the Julia set. It iterates only for 10 iterations, and it decides if it breaks, if the threshold is reached. This is basically the same code, even though I see this here. This is my crazy comparison with the fixed point number. This is my fractal tree. Okay. And this basically, this is our, it compares to 4, which is basically the same as here, because we have the calculation. Oh, okay, bye Jordi. I will leave too in 23 minutes. So now the approximated, so we have here MDZ2 and MD2, which we use for our calculations here. Is MD2? No, this isn't used for the further. It's basically calculated on the fly. However, this is the return value is an approximation of the, yeah, this is, can we, what, wait a second. Oh yeah, here. So this is calculated in real time. And basically the input position changes of the Julia set. And the ray marching works like that. The ray that we sent in the room here, let me stop that. So you have like a, here, this is you, this is you, this is your perspective. Oh, why doesn't, oh, yeah, that's here. So this is your frustum. And you send a ray. This is a ray with a direction in the room to determine the pixel. And you have the Julia set somewhere here. This is your Julia set. And what you want to know, you have like a starting value. You calculate your distance. Let's show it. This is ray marching, crash course. You want to know how far am I from the Julia set in this point. And then you just take the distance and go in this direction and check again. How far am I from the Julia set? And then go again. How far am I? And so at some point you have like smaller steps because you are closer, and then the steps increase as you are further away, and somewhere here is like you reach infinity or whatever, because you stop calculating here. Maybe you have even a bounding box and say, okay, if I'm past this coordinate, I stop rendering. So this is how let me return here. This is how ray marching works. If your array, if you look at the Julia set directly like here, and you march and get closer, this will be almost as the distance, because there might be like this an approximation, and you never touch the surface, because the Julia set, a fractal never has a proper surface. You just have this threshold where you say, okay, I assume that's the surface. So then, you know, I hit the Julia set, but you still need to get like so now you need to get the Julia set a proper shading. What you need next, yeah, you need for every point on the surface that you hit. I just rendered this point here. Yes, but it's simpler than ray tracing, because in ray tracing you calculate the intersection point of your ray, of the direction and your object. So you have the intersection formula for each object, and it's way simpler with ray marching, since you don't calculate the intersection point. You only need like as return value the approximation of the distance. So even if this has no proper intersection point in real math, you can basically get closer and closer, since the calculation of that can be really fast. Let's say intersection with a sphere is quite fast, because you only need to calculate the distance from the surface. Or let's say, yeah, so the formulas are, there is even like a list of all the formulas, distance formulas from different stuff. But it's basically similar to ray tracing. It's way simpler. It's just brute force. Because the computation is like super easy, it can be done on the graphics card, because the graphics card is optimized to do many small calculations at the same time. So you can run ray marching on the graphics card way more efficient than ray tracing. Now the graphics card have proper like implementations for ray tracing, but the computation of like intersections of different objects, not only triangles, is quite complicated. You start with line crossing formula, go up here. Yeah, in this case, you only need like the distance. And if you want to get like the normal, so the normal would be the vector that sits like square on the square on the surface. You need that to calculate. Oh shit, you can see that. Small crash course. This is not this is not a straight line. Just assume this is a straight line. Okay, this is our vector. Okay. Oh shit. Let me redraw that. So this is basically, and with that vector you can calculate. Let's say if you have you can calculate. No, wait. Ray tracing. If you want to calculate the normal, you need another formula for that. In ray marching, you don't need another formula, because you approximate it. I will tell you how in a second. Okay, so usually if we want some shading, let's assume here is our light source. And this is like the vector the vector to the point, and this is the vector of the normal. Then the dot product is basically the no, wait. Yeah, the dot product is basically the intensity of the light. So you get a shading like here. There is some specular, which are basically the highlights on the surface, but basically this is like the shading similar to that. You need the normal to calculate it. Or if you want to calculate a reflection, it's basically the same. You can calculate a reflection on the surface of any object with ray tracing, and also with, so let's assume, no. Let's assume we get, this will be our vector here, incoming vector. So we need to take this normal and basically reflect the vector. This will be the incoming, and this is the outgoing vector for the reflection. So we would start all over again our calculations with ray marching in this direction, and in this direction basically is nothing, and will basically increase with the distance of the single object. If we have different objects, this will change again. However, the approximation of the normal is quite simple, because you get the approximate distance from, let's say this, and you sample like in an epsilon distance around. You basically, this is your spot where you want the normal. You basically calculate the distance of this point, this point, this point, and this point. Basically, you calculate the delta like that, and this will give you this vector. Because there's like, so if you, wait. So you just take the delta of these vectors, and you see the delta of the distance between these two vectors is high, and this is low because the distance is close. Oh, yeah. Yeah, it's basically the same. Yeah. So you can imagine a fractal, the surface of a fractal, because it's like a fractal doesn't have a proper surface. It's unknown. It's like the event horizon, and since how is it called in English? You have your Planck foam, which is basically fluctuating in like super subatomic space, which is within the back. Yeah, that's what's happening. That's what's happening in ray marching. However, this is completely sidetracked. Okay. No, okay, this is ray marching. There are better explanations than mine. If you're interested in to learn how you can ray trace basically, you can use, you can type anything, and okay, here you go. This looks like ray tracing, but it's ray marching. And this is basically distance function. This is the distance function for a round cone. This is distance function for a prism. And basically what's happening at the end, it's basically meshed. This is map. It's basically meshed together, and you have only one calculation. Yeah, yeah, because you can. Yes, no. Which one? How Polish? What? Okay. Okay. Whatever. Oh no, this is the wrong one. Here. Um, what we can do is now we've struggled. I just kill it. Or do I new one? Oh, not saved. Oh no, this is only on stream. I hope you took a screenshot. Here we go. What we can do right now is, since we are displaying the Julia set, we are going pixel by pixel and calculating the iterations. And we have only limited time and resources to calculate the iterations right now for each pixel. And basically, for doing the multiplication of this is just the explanation for the stuff. So these three multiplications, they all take a DSP, and we have only 6 DSPs to do the multiplication. We can split them up in 18-bit multiplication, so we can do 2 per DSP at the same time. But this is a max of, we can do 3, I think 5 is the most iterations, and this is really bad. This is not a great, like, detailed Julia set. This is, you can see already here, this is 1, 2, 3, and this is only like some shape, and there's even some arrows which doesn't show properly. However, what I wanted to do now is, I don't want for 1 pixel, let's zoom in for 1 pixel here. Okay. So what I'm doing right now is I do the iterations for 1 pixel. Okay, so I was instancing like 4 pipelines that calculate, that even depend on each other. So it's not like timing wise. Yeah, the problem is you need like super thick FPGAs. Okay. No. Okay. No. No ray tracing. I don't want to do ray tracing. I just want to show you an opportunity of optimization. So what we needed right now, we needed a lot of instances for our calculation units of the FPGA for each pixel. Yeah, that's true. But I mean, this will be just a STEM session then. So now we were triggering the calculation for each pixel and calculating the iterations. Sometimes it would terminate maybe here, sometimes would terminate here, but we have the instance for the pixel, we have the instance of 4 or whatever calculation units per iteration before. And now, let's assume we want to do a buffer. So since we could, most probably, what could we do? We could do the following. Our options to improve, since we had like the possibility to use only like, let's say, what was this? This was 3 iterations per pixel. You could say, okay, we use the clock time of 2 pixels. This was our time unit before to calculate everything, and basically use our 3 units to do 2 iterations each, because we were stuck here, or even more if they can. So we could basically halve the resolution in X direction, so we don't have to buffer everything. If we need like a huge buffer, we need DRAM, SDRAM, whatever we need. We don't have as much SRAM or flip-flops in the FPGA to store a whole HD-ready frame. So we could double already by halving the resolution in X direction. We could double our calculation time and use the units twice. However, with calculating the Julia set, we could do a first in, first out buffer. Let's say the buffer, we only need to store the iteration count, which is your brain on. Okay, let's say we want 8-bit iteration counter. So we would take a FIFO of whatever, let's say 16 bytes. That's a small FIFO that fits like in a close area of the FPGA. Oh, it's not the 1080p didn't work with the timings. It most probably is the encoding. It's not the encoding of the TMDS is probably not fast enough. We have like a buggy implementation of 1080p, but I don't know what the reason is for the bugginess. So we stuck with 720p right now, and yeah, we spent like almost one stream for the like figuring it out, and you can rewatch like one of the last streams. I think it was the last one. We just determined that 1080p is with the implementation of TMDS from the example that I got wouldn't work properly. It might be possible still. It's already out of spec of the PLL clock. So at least the PLL clock, we can set it up to run with the parameters, but it's already out of spec. Yeah, the speeds you need to handle like a huge challenge without That's true. So most probably it's simpler to take like an encoder chip, TMDS encoder chip for that purpose, which costs €1, $1. If you can get them. I have a stack of those here, but I wanted to take yeah, the Tang Nano because it has already the HDMI port on the board. I wanted to use that without extra components, so it's within $20 still. Okay, we have 1 minute left. No, I will finish the explanations and we will continue in 2 weeks. Next week, no stream. Or I will stream from US. I don't know how, but I might. Okay. Now we have, let's assume we take a small, we have limited RAM and we have a small FIFO here with where we can store like iteration counts. Let's say iteration whatever 7 or whatever 7 and whatever. So now what we could do is do an approximated Julia set by calculating and the first pixel, not only the iteration count, but the distance from the Julia set, the approximated distance. Let's say our Julia set is somewhere here, symmetrical, somehow, I don't know how that looks. Okay, that looks like a, oh no. And okay, this is the Julia set. The plane, that's in LA, Lex. Okay, so now we learned from ray marching that we can calculate, oh, where's my example? Oh no, I killed it, okay. That we can calculate an approximation of the distance to the surface. Yeah. So let's assume this is our surface that, this is, shit, okay. This is the surface, so this is the inner part of the Julia set here. This is the inner, so we terminate here. So within that area, we never terminate. And this is where we terminate, and this is basically, we terminate at a different iteration. So this is the color part. This will be for a Julia set. This will be a color part. Let's say this. Okay, so like that and so on. And now our opportunity to optimize it, if we have the, I need to silence that TTS now. Okay, so when we calculate here, we can approximate the distance with the formula that we saw before. I don't have it anymore. Okay. But we know from ray marching that there is a formula, which is a little bit more complicated because we need the log. But this can be stored in a lookup table, and we can approximate the distance. And what we know there is that we can store in our FIFO basically that this pixel will last at least for that size. So we would terminate within this distance, and we store like the iteration count and the distance or whatever. So we continue with our calculator while the TMDS is encoding this pixel, this pixel, this pixel, this pixel. It only is, the TMDS only reads from the FIFO here, while it says, oh, it lasts for so many pixels, while we continued calculating here and stuffing it in the back of the FIFO here. So we continued there, we calculated a new distance, which will end up somewhere here. And this will be the second entry of the FIFO, while the TMDS is still encoding here. And this is the next, this pixel. So basically, we use the really fast terminating area to get ahead of the TMDS, and then basically optimize that. And when we are in this zone, which takes the most time to calculate because it doesn't terminate, the TMDS catches up. So we just set the maximum iteration count, so TMDS will never overtake us, or we just draw black. If the FIFO is empty, we can draw a black pixel. That's all. So we can set the size of the FIFO, and we can use the distance formula to calc ahead. But that's only one option for that. And it will be strangely colored, because we have like, we draw a like a horizontal, yeah. What is this? What is this? I don't know. This is completely unrelated. Okay, peeps. Unfortunately, I wasn't able to code, but I will keep you updated on that. So this was my last state. I will take the development with me to US. I might be able to stream there as well. I don't know how well it works. If I have a good hotel with Wi-Fi, I could even stream next Wednesday. I have no clue where I am. I have not booked anything for Wednesday. And what time will it be? Oh, it'll be midday. Yeah, let's see. Let's see how it works. Maybe I'll only stream on my phone and show you what I accomplished. But now I have to say goodbye. Sorry, it wasn't as much FPGA coding as I wanted. But yeah, we did other stuff. We fixed my laptop. Well, my flight. Oh no, yeah, there. Yeah, I don't know. I will even maybe switch time zone. Colorado is different time zone than California, isn't it? Time to say goodbye. Yeah, my flight goes in 18 hours. Oh, I need to pack, sleep, and everything. Ah, panic! Bye bye. Ah, where's the? Oh no, this is not. Yeah, I enjoy streams with you people as well. Thank you for all the donations for today, and the patience with me. I mean, I didn't have videos for a long time now, but I'm in the rabbit hole. Oh, I'm flying to the SuperCon. So I will be at the SuperCon tomorrow. From tomorrow, for the next 10 days, I will be in the USA. So, see you, friends, and have a nice week. Bye bye.